Okay, student. Now in the limitations of Envelope-Data, I think you clear. Okay. Why you are adding a DC component and all these things? Listen carefully. The DC component added to the message signal before go for modulation only for sake of successful operation of envelope detector. Okay. So envelope detector will not do any mistake. The envelope detector will always successfully working only when the modulation index is less than or equal to 1. So if you make mu less than or equal to 1, always add a suitable DC component. And some of the students are asking a question that I don't want envelope detector, sir, then what should be your answer? So if you don't want envelope detector, no need of envelope detector. If anybody is not interested on envelope detector, but everybody must and should interested on envelope detector, the purpose is the envelope detector is less cost, less complexity, simple circuit, simple design, easy implementation. So why we want to lose those particular features? So if no need of envelope detector is your decision, then at the transmitter side, now this is message multiplied with message plus DC, no DC, nothing, no DC, multiplied with carrier directly. Means this is the modulated signal. So this is an amplitude modulated signal, which is nothing but message just multiplied with carrier. This is without DC. Now without DC, without any DC, this is the AM signal. Understand not? Now if you don't take any DC, message and multiply with carrier, this is AM signal. But the demodulation, receiver side, who will not work? The receiver side demodulation is not done by envelope detector. This is the condition. First you remember. Clear or not? If you don't want DC, there is no envelope detector. If you want DC, then there is a chance of envelope detector. Okay. Now definitely there is a chance of over modulation. Sir, in such a situation, then what should I do? Yes, there is another demodulator which is called a synchronous detector. That also we'll see. Okay. Clear or not? Now for saving this, I add DC component. Okay. Now anyway, so the purpose of Ka is, what is Ka? Ka is normalizing the peak amplitude of the message signal. Okay. Now this is input to the envelope detector. It is input to the envelope detector, and this is output of the envelope detector. Now 5 cos 2 pi into 10 power 3t is the input to the envelope detector. Output of the envelope detector is 5 volts. Now AC cos 2 pi FCT is the input of the output detector. Output of the envelope detector is AC. Now AC into 1 plus Ka into m of t into cos 2 pi FCT is the input to the envelope detector. Output of the envelope detector is AC into 1 plus Ka into m of t into cos 2 pi FCT. So this is nothing but AC plus AC Ka into m of t. Not a problem. By using blocking capacitors, you can block this AC component and you can block this one also. Then you can get only m of t is the output of the envelope detector. Okay. But now see here, the same situation here, but AC into 1 plus Ka into m of t into cos 2 pi FCT. Now this is, now here mu is greater than 1. Here, over modulation taking place. Over modulation occur. Over modulation. Then what happen? Already I am saying that whenever a over modulated signal is applied to the envelope detector, what happens? Now the negative peak will become positive side. The negative voltages will go to the positive voltage. Alright, negative voltages will also go to the positive side. Therefore, the output of the envelope detector is modulus of AC into 1 plus Ka into m of t. This is a negative voltages will become positive voltages, and this is a modulus. Clear or not? So whenever over modulated signal is applied, and this will be happening. And next, A cos 2 pi fct plus B sin 2 pi fct is the input to the envelope detector. Output of the envelope detector is square root of A square plus B square. Why? Because so this is the input, then the envelope, the peak amplitude is nothing but square root of A square plus B square. Okay. So this is the input to the envelope detector, and this is the output of the envelope detector. With operations, you can easily understand this. Okay. And you tell me if this is e power minus t into sin 3t is the input to the envelope detector. What is output of the envelope detector? Will just track the peak, track the envelope. Therefore, output, which is nothing but e power minus t. Why? Because this is nothing but exponentially decaying. Okay, this is exponential decaying. Now, these are the peaks. Now, this is peaks. This is the peaks. The peaks is nothing but e power. Okay, this is the input and output of the envelope detector. No doubt. Now, based on this envelope detector, now one question is there. Now, in our classroom workbook question number 14, I think. Classroom workbook question number 14. Consider a system as shown in the figure below. Consider a system as shown in the figure below. Now, this is the system which is given to you. A high pass filter whose cutoff frequency is given as 100 megahertz. Now, this is connected to the adder circuit. This is the system which is given to you. Now, what he is asking is, by considering this signal, sorry, by considering this system, and he is asking to find output of the envelope of the output signal. Now, this is the output signal. Whose envelope he is asking to find? Now, first you find what should be the output signal, and after that we will see the envelope. Okay. Now, what is question number 4 is, consider the system as shown in the figure below. Determine the envelope of the output signal. Whatever output signal, now that envelope he is asking. Now, first you find what should be the output signal. Okay. This is the PM, means product modulator. Product modulator is nothing but multiplier. Okay. Now, can I say like this? This is AC cos. High frequency means I just take it as a carrier frequency. This is low frequency means I can take it in this AM cos 2 pi Fm into T. Now, this is the output of the multiplier. The output of the product multiplier is AC AM cos 2 pi FCT into cos 2 pi Fm into T. Now, this is 100 MHz signal, 1 volt amplitude and 90 degrees phase shift. Now, the output of product modulator is, can I write like this? AC AM by 2 into, I multiplied with 2 and divide with 2, cos 2 pi FC plus Fm into T plus AC AM by 2 into cos 2 pi FC minus Fm into T. Now, this is multiply and divide with 2 cos A cos B, cos of A plus B, cos of A minus B. Now, 100 plus 1 MHz, 101 MHz, 100 minus 1, 99 MHz. So, this is a high pass filter. It is passing through the high pass filter whose cutoff frequency is 100 MHz. Now, the frequency is greater than this cutoff frequency is allowed and the frequency is less than this cutoff frequency is not allowed. Okay. So, this is the output of the high pass filter. Now, the output of high pass filter is AC AM by 2 into cos 2 pi FC plus Fm into T. Now, this output of the high pass filter is added with 100 MHz signal means carrier frequency, 1 volt means AC, but 90 degrees phase shift. Can I write like this? This is AC, this is cos, therefore 90 degrees phase shift means sin. AC sin 2 pi FCT. Therefore, the output of the adder is AC AM by 2 into cos 2 pi FC plus Fm into T plus AC sin 2 pi FC. Now, this is a signal finally AC sin 2 pi FCT, AC sin 2 pi FCT plus AC AM by 2, AC AM by 2. Now, this is, I just expand this, cos of A plus B. Now, cos A, cos B minus sin A sin B, AC AM by 2 sin 2 pi FCT sin 2 pi Fm into T. Now, finally, the output signal is, what we can get it is, now here sin 2 pi FCT is taking as a common. If you take sin 2 pi FCT as a common, this is AC AM by 2 into cos 2 pi Fm into T into cos 2 pi FCT, cos 2 pi FCT plus sin 2 pi FCT as a common, AC minus AC AM, AC minus AC AM by 2, AC minus AC AM by 2. Now, this is sin 2 pi Fm into T. Then, if you take it sin 2 pi FCT as a common, sin 2 pi FCT. This is the output signal, right? Now, this output signal, now what he is asking? He is asking envelope of this output signal. Now, the envelope of this output signal, which means that then if you connect it to envelope detector, you can get the envelope, right? So, what is the output of this envelope detector? Now, Can I write like this? This is A cos 2 pi FCT plus B sin 2 pi FCT. This is the input to the envelope detector. This is the input to the envelope detector, and the output of the envelope detector is square root of A square plus B square. This is square root of A square plus B square. Already AC, AM values are given. AC is 1 volt, AM is also 1 volt. You can utilize that. So if you take this one, the output of the envelope detector is square root of 5 minus 1 by 4, 5 by 4 minus sine 2 pi into 10 power 6 into t. This is the output of the envelope detector. Okay. See here. This is product modulator, or sometimes it is balance modulator. Okay. Very soon we can understand. A product modulator or a balance modulator is nothing but just a multiplier. Now this is AC 1 volt. High frequency means I just assumed as FC. Now 1 volt is message signal amplitude. Low frequency means I can take it as message signal frequency. Now this is the multiplier. Now here what I just doing is AC AM. I just multiplied with 2, divide with 2. 2 cos 2 pi FCT into cos 2 pi FM into T. Okay. This is the output of product multiplier. So this output you can write like, okay. So I just multiplied with 2, therefore 2 cos A cos B. Now cos of A plus B plus cos of A minus B. Now this is 99 megahertz, this is 101 megahertz, but here the cutoff frequency is given. High pass filter cutoff frequency is given as 100 megahertz. Therefore, the frequencies less than this cutoff frequency is eliminated. The frequencies greater than this cutoff frequency is accepted, and addition of adder, and that is added to the signal, and this is the output of the envelope detector. Okay. Like this also sometimes the questions are asking. So envelope detector, you know what should be the input to the envelope detector and what should be the output of the envelope detector. Okay.